Hey, grade 11. So we're back with chapter 7.5, and this time we're looking at piecewise and step graphs. So here we've got two linear equations, y equals 2x plus 1 and y equals 4x minus 1. And basically what we have to do is, as the name implies, piece them together. Now, with piecewise graphs, there can be no gaps different to a step graph. So effectively, if you have two equations, they should be meeting at one exact location, okay? To find that, what we're going to do is make these two equal to each other. So if y is equal to 2x plus 1 and y is equal to 4x minus 1, then they're both equal to one another. Now, once I've done that, I'm then going to rearrange and solve. So I'm going to move this minus 1 over here, making it a plus 1. I'm then going to move the 2x to the other side, making it a minus 2x. We end up with 2 is equal to 2x, or 1 is equal to x, because the opposite of timesing by 2 is dividing by 2. 2 divided by 2 will give you 1. What this now is where our intersection occurs between these two lines. Now, I could go and prove the y coordinate. In fact, I might do that just so you can see where it's coming from. So we'll take this, let's just sub it back into the original equation up here of y equals 2x plus 1. 2 times 1 is just going to be 2. 2 plus 1 is going to be 3. So what we now have are our two intercepts. I'll just clean this up a little bit. Okay, that is our coordinate for where these two lines will intersect. And I'll go ahead and prove that now. So we've got y equals 2x plus 1. Yep, and then y equals 4x minus 1. And you can see that if I zoom in, that little coordinate there is 1, 3. That's where they intercept. Now, you'll notice they have a domain attached to them. Okay? This first line goes up until it hits that interception point, okay? And that x value was 1. So to put that in Desmos, here's what I'm going to do. X is going up to 1. Now, notice what it's done there, grade 11. It's going, it's going, it's going. It stopped at the 1, 3, and now it's time for the blue line to take over. But if you have a look, this blue line is going at the same time as our red line, and we don't want that. So again, we set up a domain, but this time instead of going one way, it's going the other. And look at what's happened here. Notice they're both either less than, greater than, or equal to 1, because they both share that x is 1 value in common, okay? And you'll see that it zigzags right there. So that's how we do our piecewise graph. It's going to go on infinitely. I could keep following that, but there's no point, okay? We have that one point which defines our piecewise graph here, okay? So that's how we do it with technology, okay? Showing you the ropes there. All right, I'll take a quick screenshot of that so you guys can see it. There we go. That should be good enough for you. I'm just going to paste it in. So we originally went through the proof. Let me just shrink that a little. Or a lot. Let's get it back onto that previous page. If you wanted to obviously blow that up, you could, but that's how we do our first piecewise graph. Now we're onto something a little bit harder, okay, and that's a step graph. Okay, this is where it's going to get a little harder. Now, what we have here is we've got y equals 1, y equals 4, and y equals 6. I'm going to just quickly put those equations in here. Let's clear this. So we had y equals, what was it, 1, 4, 6. So y equals 1, y equals 4, and you can already see it's asking me to prompt the step, so it understands that's what we're trying to do. We could just enter them in there, but there's a bit of an issue with that, okay, and it's to do with these, but ultimately Desmos can't help us with this, so I'll be going through showing you how to finalize it in just a moment. Now, as I zoom out, you'll notice I don't quite have 6 on here. Alright, so we've got a red, a blue, and a green line. Hopefully they're pretty easy to see, guys. Now, what we've got to do is put the domains in for each of these. Now, my y equals 1 goes from -3 to 2. Now, notice these signs. One's greater than or equal to. Alright, so let's go. We've already got our bracket open, I hope. Yep. So -3 greater than x, and then greater than or equal to 2, wasn't it? Yep. Okay, there's your first one, and as you can see, it's done it perfectly. Now, the next one, 2x has to be greater than 2. Whoop, that's not inside there. 2x has to be greater than 2, but then 4 is greater than or equal to x. It keeps doing that. Okay, oops. There we go. There's my second one done. Notice there was no gap along the x-axis for that one. We have to do a little bit more to it, but I'll talk about that in a moment and show you how I'd do it. Now, I was going to handwrite this, but I decided against it for this video, just to make it a little bit easier. So let's go through and do the 6 now. So for just like all of our others, okay, you'll notice they carry down. And then this one is going up to 6, I do believe. Yep, there we go. So what we now have is our piecewise graph that you should be able to see. I'll just zoom out a little bit. And what I'm going to do is I'm going to snip this, because we actually still have a little bit to do. Now, this is why I actually tried to set up an actual recording, of a handwritten recording for this, because I need to explain how to interpret the different greater than signs, be it greater than or equal to. Okay, so what we'll do, and I know this might seem a bit rudimentary, but we're going to put it into Paint. Okay, I'll just try. Whoop, way too far. They don't really give me an option, do they? I'll keep it at 100%. That's probably going to be the easiest to do. Now, let's start with our y equals 1, our red line. Okay, just want to make, yeah, you can definitely see it. So we've got -3 to 2. Now, when we do something like this, okay, we have to put circles on the end of each of our lines to indicate whether it includes that endpoint. Okay, sometimes the stepwise graph can share or not share. All right, and it's all about distinguishing that. Now, the first one is x cannot, and I'll repeat that, cannot be equal to -3. Let me show you how we do that. So I'm just going to quickly set my second color. You'll see why in a moment. I'm going to draw a little circle. Don't be afraid if it crosses over the actual value. And with this circle, I am not going to fill it in. That indicates to me that x cannot be -3. Think of it like a little barrier keeping our x value from reaching -3. We know it can't reach -3. It's being pushed away from there. Okay, it can be -2.99999 recurring. It can never be -3 though. Now, going along to our next one here, okay, it goes up to, and it can this time be equal to 2. So again, my circles may not be the same size, but I'll try my best. To distinguish this between our greater than and our greater than or equal to, all we simply do is fill it in. That indicates that it can be part of that point, okay? There's no barrier there, all right? Over to the next one now. Now 2 for the next one, it cannot be equal. So I have to get rid of the fill. Okay, it's an open-ended like that barrier again, keeping it away from being equal to 2 on this line. It can equal 2 on our red line, not on our blue line. Next up, we've got greater than or equal to 4. Oh, no, I might redo that one. That was a little too big. It's a little better. And we can fill this one in, okay, because it can be equal to 4. And last but not least, you'll see the process is actually following the same pattern here. Okay, now it won't always follow this pattern. Okay, so just be aware. Okay, I know, like particularly with my classes, I do like to try and trick them a little bit, just to make sure they are actually paying attention. So here, There we go. That is our image, okay? What I'll do is I'll put this onto the worked example for you so you can see that. Sorry, I should actually select all of that. There we go. So that's just going to go back onto our worked example here, and that's how we do. Fingers crossed it works. Just thinking about it. There we go. I know it may not look the neatest. I would have actually preferred to hand draw this, but this gets the message across just the same. Okay, so you can see there. Just be aware, we do like to change it up a little bit, so just make sure you're paying attention to them. Okay, sometimes they'll have two just greater than signs. Sometimes they'll both be greater than or equal to. You need to pay attention to that. All right, we might even throw a few ones where we do x equals instead of y equals. Okay, but that's how you do your step graph for that one. Finally, consider the following linear graph that makes up a piecewise linear graph. Now, again, if you want to, you'll see here we have three equations. The way it's going to work is basically, and I'll draw a little tool for this one, okay? What effectively is going to happen with this is you're going to end up with a graph that comes along. If this was your Cartesian plane, oopsie. Keep forgetting with Word, you have to never let go. But effectively what it's going to look like, I'll just do a little scribble, is bang, then the one's going to stop, then it's going to go a bit steeper, and then it's going to go a bit steeper. Again, obviously not that high or, vertical for that matter. But what we effectively have is we're going to have two intersection points. Now, that doesn't mean that all three intersect in 2 points. What I mean is, for these two, the y equals 2x minus 3 and the y equals 3x minus 4, they're going to have one intersection point. Okay, and that intersection point is known as A. Okay, and it's only talking about the x value of A, not the whole coordinate. These two, on the other hand, the 3x minus 4 and the 5x minus 12, they're going to have an intersection point. Okay, now how I'd start this, I'll quickly delete all of these. Delete, delete. Okay, so let's start by putting y equals 2x minus 3 in. There is our linear equation. Now, again, we're attaching a domain to this. But before, we know that it's obviously going up until a certain point, but we don't know what that certain point is. To find that, we could do it algebraically like in the previous question, but I'm not going to do that. What we're going to do is we're going to draw in our second line. So new line, y equals 3x minus 4. And there we go. Now, as you can see, they will only ever cross over in one point, and that point is right here. As I zoom in, it is the x is equal to 1 value. Okay? So what you could do is there's two ways you could write this domain. We're going to do it with relevance to the x value. Okay? And in this case, again, putting our domain, x is going to go up. It's greater than or equal to, yep. And a in this case was x equals 1. Watch what happens. It stops. Now for our second line, we know that now x is going to be bigger than 1. And now what we've done is we've set up a piecewise graph. But now it gets a bit more complicated because we have a third line, y equals 5x minus 12. Now, in an exam setting, I would expect you to do something like this, say, in pencil, and then go back and do it in pen when you're finished, just so you can, erase the line if you've gone too far. Now, zooming out, we can see the intersection point right here, 4 and 8. The x value, of course, being 4. So what we know with this one is that while for our black line, the x had to be bigger than or equal to 1, we know here that it's going to stop at 4. Okay, so you notice how the black line has now stopped there? And now we're going to have one last thing, because what we need to do is, you see this red line? We need to trim that a bit. Okay, we need to cut it off beforehand. So we only want x to continue on past the x value of 4. Oops, wrong bracket. There we go. All right. As I zoom back out, if you remember what I said, I know I didn't draw it as accurately as I could have, but you can see the different points and the crossover that they're making. Okay, that's probably going to be the best, I reckon about the best there. Okay, So I'll snip that and put that in our image as well, just so you can see, how I got some of those figures. But hopefully that helps you in terms of how to construct a piecewise graph. It's actually incredibly easy when using technology. Yes, drawing it out can take a bit longer, but it's still a skill that you may need to have for your exam. Okay, and yeah, that's everything in terms of piecewise and step graphs, guys. Hope you enjoyed.